in this lecture, we will learn about the theory behind scatter plots and the origin of R value in scatter plots. So I want to give you a little bit of background of the theory behind how we get the values for correlation coefficient. I'm sure in our basic course you learned that the correlation coefficient represented by rho or R is usually between -1 and +1, and for values greater than 0.8, either 0.8 on the positive side or 0.8 on the negative side, we consider the data to have a strong correlation. And for values which are less than 0.8 but greater than 0.6, we consider that to be a moderate correlation. And anything that is less than 0.6 downward to 0, we consider that as very low correlation or no correlation. What is the theory behind the R value? So let's probe a little bit on that direction and understand that. Galton and Pearson were the people who are working on this. For a long time, they took the X and Y values of each data point, multiplied them, so they did X into Y. So they got XY for each dot, and they try to play around with that to find out if they can characterize the relationship between X and Y. But their efforts were not fruitful for a long time, till they realized that if they fit a normal curve such as what I have done here. So on the top you have a normal curve for the X data or a distribution of the X data, if I were to generalize that, and I have a distribution of the Y data on my left side. Then they started computing the Z-scores. I'm sure you know about the Z-scores that we learned earlier. So they normalized this data and they found out the Z-scores. The Z-scores for the curve on the top, that is for the X values, would be on the plus side. So you would have plus values of Z-scores onto your right side, and you would have minus values of Z-scores to your left side. Similarly, for the Y-axis as well, on the upper side you would have plus values of Z, and on the lower side you would have the minus values of Z. So instead of finding the product of X and Y, they started finding out the product of Zx and Zy. So now when you take the product of X and Y, and when the signs of X and Y are different, then of course you would have negative values, and likewise when the signs of X and Y are same, you would have plus values for the product. They use this as the rationale to build the relationship. Correlation coefficient R or rho is nothing but sum of all the Z-scores, the product of the Z-scores between X and Y, divided by the total number of pairs that we have. In other words, total number of data points that we have. We need to rationalize this by the total number of data points we have. So they did that. Thus, the value of R would be either a plus value or a minus value depending on the direction of the dots. If the dots formed a pattern and they were pointing towards the 2 o'clock, then we would have positive Z values. And so we would have positive R value. On the other hand, if the trend or if the direction of the dots were pointing towards 10 o'clock, then we would have negative Z values. In other words, negative R value. Thus, they arrived at the formula for correlation coefficient. So this is a little bit of a background about correlation coefficient. In the next lecture, we will talk about how do we represent the relationship between nonlinear data. Thank you.